Going to understand today Leetcode problem, and the question is Leetcode 790, and it's a domino and tromino tiling problem. Okay, so let's read the question and go through the statement. Okay, so it is saying that you have two types of tiles, 2 into 1 domino shape and tromino shape. Okay, you may rotate these shapes given integer n, return the number of ways to tiles and 2 into n board, and since the answer may be a very large, return it to modulo 10 to power 9 plus 7. In a tiling, every square must be covered by a tiles, and two tiling are different if and only if there are two 4 into 4 directionally adjacent cells on the board, such that exactly one of the tiling has both square occupied by tiles. Okay, so let's suppose that we have given here is what, right? Domino means there will be 2 tiles, right? And tromino means 3 tiles, right? And we have to return the number of ways to tile and 2 into n board that we have to do. Okay, so just pause this video and go through this statement, right? So it will be good for you to understand the problem statement. So let's continue from here. So the problem is saying that you are tiling a 2 into n board, right? And using a domino, and this domino is 2 into 1, you can say, as you can see here, or 1 into 2, right? And there is a tromino, right? So tromino is L shape, right? And there will be 3 tiles, right? And we have to return the number of distinct tiling modulo we will take 10 to power 9 plus 7. Okay, and the key observation is here. So let's suppose if we will take a f of n, right? The total number of ways we will calculate to 2 to power n, right? Let's suppose 0 into n, so 2 into 1 will call, right? So the function that we will take, function of n, let's suppose, will be the total number of ways to tile this board, right? So we will use a function of n using f of n minus 1, and we'll add vertical domino. We'll take f n minus 2 and we'll add two vertical dominoes, right? So see, if we'll put the vertical, right? This will put the vertical. So when we pass f of n minus 1, right, means we'll say this is a vertical domino, right? So when we are adding vertical domino, right, we'll take f of n minus 1. But when we do f of n minus 2, means we add two horizontal domino. Okay, so when adding the vertical, we'll add f minus 1. Okay, function at n minus 1, and we'll use the vertical domino to add. And when we go for the horizontal, we'll do f n minus 2, right? That we will build the function like this, right? So if we'll talk about the L shape, if we want to add L shape tromino, so in the orientation you can say, so we'll take 2 into p of n minus 1, we'll say, and p of n means the number of ways to tile the board where one square is missing, right? Because there is one square is missing here, right? So we'll do 2 into p of n minus 1, and p of n is what? The number of ways to tile the board where one square is missing, right? So the best way to understand is to go through the example that we have given here. So example first we have given n is 3, output is 5, right? So the 5 different ways are shown above. As you can see, these are the 5 that we have given here. So 2 tiles is here, 2 tiles is here, 2 tiles is here, right? Then we can do like this. We can show this vertical one. These are the tiles that we can see, and there will be 2 L shape will be there, and we can provide this L shape, right? Like that, these are the 5 ways we can show. If there is n equal to 1, so we can show only 1, right? So the constraint will be n is greater than equal to 1 and should be less than equal to 1000, right? So we have to do the coding, and to do the code we have given this L shape one. You understood, right? needs to do, right? So first of all, as you know, right, we have to handle some base cases because this is a DP problem, right? And so we have to handle the base cases, right? So what was our goal? Our goal was to count the number of different ways you can completely fill the 2 into n boards, right, using these tiles without leaving any empty cells. Also, the two tilings are considered different only if the pattern of the tiles placed is different, right? Since the numbers can be used, so we have to take also the modulo, right? So for example, we had given what n is equal to 1, so we will have to return the board as a 1, right? Because let's suppose if there is a two uh, you can say uh, 2 into 1 board, right? Let's suppose, right? So if n is 1, let's suppose this n is 1, it means what? We have the board 2 into 1 means there will be 2 and 1, right? 2 into 1, this will become 2 into 1, right? So the only one way to tile it, we will use one vertical domino, right? And we'll say n equal to 1, and so the output will come is 1. We cannot re-represent it again. We cannot provide the different ways to fill it, right? And so we will returning the answer as a 1 if n is equal to 1, right? Now think, if n is not 1, right, then what we will do means we have to handle some cases that we will implement, right? So first of all, the first step, we have to handle the base cases, right? Base cases, right? So how we'll handle the base cases? We'll write if n equal to 1, will return 1, right? If n equal to 2, will return 2. So the two base cases will write n equal to 1, n equal to 2, right? And so the answer will come 1 and 2. Why n equal to 2 is coming 2? So let's suppose we have, if you have n equal to 2, right? Then how will you write that? So you will write the base case is like this, right? Sorry, the tiles you will write like this. So the ways to tile this is 2 vertical domino and 2 horizontal, right? So the different way you will implement, still you will see it will come like this only, right? Right? If you write the vertical or you will write this, right? So means there is only two ways. Either you will write vertical dominoes or horizontal verticals. Means maximum two ways is there, right? So n equal to 1 and n equal to 2 is what is the base cases, right? What about n equal to 3, right? So when n equal to 3 means you are doing what? 2 into what? 3 means total how many board will be there? So your board will be like this, and there will be 2 into 3. So you will write like this, right? So we will write 2 into 3, and for that we have 2 into 3 board, right? So the number of ways we can represent is, let's suppose 3 vertical dominoes you will write, 3 vertical dominoes and 1 vertical dominoes and 2 horizontal dominoes. So let's suppose if we have this is the 3 dominoes, we are using a vertical and 3 horizontal. So if we will write 1 vertical one and the two horizontal one, let's suppose like this, okay, we can do the same we can do the same thing in the backward, right? Like this, right? Means the first of all we were doing what? 3 vertical, right? And 3 downward, right? Means 3 vertical dominoes if you will put, it will come like this. Horizontal we are doing, right? 3 horizontal we are doing. We can also add 3 vertical also, okay? So there is a good example. And then we'll add 1 vertical and 2 horizontal, right? As you can see. Similarly, we can, because we are doing we are also making the L shape, right? Facing one direction. Oh yeah, there is one more thing, like 2 horizontal we can do. Let's suppose 2 horizontal we can do, right? And 1 vertical, sorry, 2 horizontal and 1 vertical we can do. From here I can get the idea, right? And we can we can rewrite like this, right? So there is more chances to write like this, right? Total number of the verticals we can do, right? And so there is 5 total ways will come, like one vertical dominoes, one vertical and two horizontal, one vertical, one tremino like L shape we can make, and L shape mirror one we can do that, right? Means total 5 cases can come. So the in the real world, what will happen? Imagine you are telling a bathroom wall that's two tiles are there, tall and n is tiles is wide, right? And you have only one rectangular and L-shaped tiles, right? And you want to find out in how many ways, different ways, you can cover the whole wall without gaps or overlaps, right? So you have to think like in the real life, and then you have to implement it. Okay, so just think that these are the two base cases we'll take. There will, you can add multiple, but that will not your base cases, right? So the base cases is that the minimal smallest you can say the case that can be repeated, right? And where the dynamic programming recursion should stop, right? So the base case will become n equal to 1 equal to 1 and n equal to 2 is 2, right? When n is equal to 1 or 2, we have to return like this, right? Next step, what we should do, we should create an array to store the computed value that we will do, right? So what we can say, let's create a arrays to store the computed values. Suppose we have a function that we are talking about. Let's suppose function at 1 or not 1, I. Function at I will say number of ways to fill to cross I board, right? And then we can write what? P at I. So those two functions will there, right? That we have talked. So this will be a helper count, you can say helper count for Tromino. First is for domino, and this will be for Tromino. That is a placement pattern, we can say, right? Placement patterns we can say. So if we'll write the long, we can write long as a type, and we can add dp, we can define, and we'll say long n plus 1. Okay, another we can take log at, you can do format letter, right? And then we can write what? P, dp, and p will take, and we'll say new log and n plus 1, right? Let me do little formatting so it will become good. Sorry, like this. Okay, now what we should do, actually this will become for we can say dominoes, right? F of n, and this the function of function at 1, right? And p at 1 n, right? So this will be the, this is the way we can store the computed values while moving, right? Next thing, initialize the base cases. So let's suppose next step we can say initialize the base case value, or base values, we can say base values. How? Means dp at 1 is 1, initialize this value dp at 1, then dp at 2 we can say, and this will become what? 2, and p at 2 is 1, this. Okay, so these are the values that we can do, right? So let's suppose when we have dp at 1 is 1, means when only one vertical domino is there, right? Then we are getting, you can see the example, right, that we have already given. and when there is two vertical dominoes or horizontal one, right? Two vertical domino or two horizontal one domino. In that case, we will see these cases, and other will be one L shape, right? This will be for one L shape trominos can fit at n equal to 2. So these are the cases we have to initialize, and so we have to write, right? Like these cases we have to write. Now think, we will loop from what we have already done. So we can start from the loop. We can start the loop, for loop, and this for loop will fill all the dp and array as well, right? So we can start I equal to what, from 3, because 1 and 2 we have already done. So we can start from 3, and I should be less than equal to n and I plus plus, right? So the first step we will use to we will write what, compute through the recurrence, right? And the recurrence formula will be what, p at I is will take, there will be let's suppose mod, we have to take also mod, right? So take p at I minus 1, and then dp at I minus 2, and then we'll take the mod, right? We'll talk about later what is mod here, okay? So we'll define this mod later. Now compute the function one, right? This is the pi. Then we'll talk about the dp at I. What will be the dp at I, right? So dp at I will be dp at I will be what? Same we'll talk, same will create like this. Let's suppose we'll pass dp at I minus 1. Yeah, I mean, because we are down, right? Okay, dp at I plus dp at I minus 2, and we'll do plus 2. Then we'll do multiply p, the function. Remember the function I was talking about, I minus 1, and we'll do what, mod, right? The mod. Now we have to return dp at n, right? And so we have to convert into int if anything is there, long is there, right? So we will convert into integer. So what we are doing here, so first we are computing the pi, right? And because this will come from the recurrence, right? And similarly we will also compute dp at I to compute the function at I, right? So we are calling both, and we are writing this, right? And so no, we should not go here, we should come out of this, right? Because the function got completed, it should not return in the first time, okay? So we will return the final result for f of n is here, okay? So what we are doing here, so we are returning the final result here, right? Final result we are returning for f of n, right? And here what we are calling, we are computing the p at I here, and here we are calling, and here we are calling what, function at I. So if you have these things ready, you can calculate, and you can write the you can say this domino and tromino you can calculate and you can write in the array, right? Now what you can do, you can define the mode here that we are talking about. So let's create a private, write the static int, and this will be your mod. We'll write 1 underscore 000, then we can write 000 007. Okay, let me run it and submit this. Yeah, thank you guys, thank you for watching this video. Let me know if you have any doubt, right? And let me know if you have any doubt in this video, and I hope you understand the problem statement, right? And the coding you understand, right? So what we have done in this video, right? So we have defined the mode, that because 10 to the power 9 plus 7 we have done. So we have to take the constant, then we have to handle the base cases, right? If n is equal to 1 and n equal to 2, right, then we have to handle that. Then we have created two array, dp and p, to hold function of n and p of n values. And then we have set the initialize value dp at 1 and dp at 2, we have initializes. And then we have loop from 3 to n. Then we have calculated p at I. What is p at I? Let me read the here, p at I. So p at I, let's suppose function at I is p I is p at I minus 1. This is the function, and here we will write dp at I minus 2. Okay, and if we'll talk about the function, so we'll write the I, and it will come like what we call dp at I minus 1, dp at I minus 1, and then we'll write the function dp at I minus 2, and then we'll write 2 into p at I minus 1, right? So like this we have to rewrite. Then better, let's write right here. Oh, sorry, and we can write this here. Okay, so this will be a little easy for you to understand. Okay, so first of all, what we have done, we have defined everything. My modulo we have defined, base cases we defined the array, then we have set the values, initial values, and then we have made the loop from 3 to n. Then we have used p at I and dp at I, and then we have made we have calculated the values, and we have stored on the dps arrays, and then we have returned the dp at n, and we have converted into integer because we have defined in a long, right? So that's all for today, guys. Let me know if you have any doubt, right? And I hope you understand the problem statement, very well, right? And thank you for watching this video.